Hi and welcome to this Leaving Cert Higher Level Applied Maths video. In this video, we're going to look at a previous exam question. So this is from the SEC sample higher level paper. It is question 3, part A. This is looking a little bit about deriving using calculus and expression for S. I go through these derivations in a lot more detail in the video linked in the description below. So a particle has initial displacement SO, so S0, from a fixed point P. It moves away from P with initial velocity U and constant acceleration A equals dv dt and d squared S dt squared. So we have two formulas here for acceleration. Use acceleration to derive an expression for S, the displacement of a particle from P at any time t. So a few things to note. We have a constant acceleration, meaning acceleration is a constant, and we can let that equal a. So let's start off with a, and we're going to use dv dt, just the first derivative, to get us going. Let's break this out. So we get a dt is equal to dv, and we're going to integrate both sides. So when we put our limits of integration here, when time is 0, our velocity is the initial velocity, which we use as label u. And when time is t, so at some point in the future, we have the final velocity, which we have the letter v for. So then on the left-hand side, we get at, and we're going to evaluate that between 0 and t. On the right-hand side, we get v, and that is evaluated between u and v, giving us at minus a times 0 is equal to v minus u. And then rearranging that, we're going to get v is equal to u plus at, which is a formula for the velocity at any time t. Now we were asked to derive an expression for S, the displacement of the particle, from P at any time t.